grade, welcome to our screencast on connecting visual models and the distributive property to partial products of the standard algorithm without renaming. That is basically one big long objective to say that we are going to connect a bunch of different multiplication strategies. So we'll start by reviewing some patterns when multiplying and we have a lot of zeros in the factors, and then also multiplying multiples of 100. So I know 31 times 1 is 31, and there are two zeros, 1, 2, 1, 2. We are familiar with this strategy. I now know that I can do 31 times 2, so if I double that, can you do that mental math? 62, and there are two zeros, 1, 2, 1, 2. 31 times 2 is 62. And how many zeros? 1, 2, 1, 2. Oh, that's interesting. And then finally, 31 times 2 is 62. And how many zeros? 1, 2, 1, 2. Look at that. Even though we have different factors, we got the same answer 3 times. However, 31 times 2, 31 times 2, 31 times 2 are all part of these factors, and we have the same number of zeros in each question. So this makes sense as long as you go back and you realize why we're getting the same answers. All right, let's move on to the next problem. Now, before you write all of this next chunk, look at how much that is to write. You don't actually have to write it. So if you are listening to the directions of this screencast carefully, you just saved yourself a lot of work. I even wrote on the side, don't write. That will take too long. And really, I just want to go through this problem together with you so you can see that there's more than one strategy that you can use to solve it. So, Anisha is setting up a play space for her new puppy. She will be building a rectangular fence around part of her yard that measures 29 feet by 12 feet. How many square feet of play space will her new puppy have? Okay, so I'm picturing this. She has a rectangular yard for the puppy. This length is 29 feet, this length is 12 feet, and I want to know the area of the inside of the rectangle. So the first method that we could use, you'll notice I put method A on this side and then method B on this side, was I had to determine I'm multiplying 12 times 29. And another way I could say that is I have 29 12s. So I can break this 29 up into easier numbers to work with. And this is like using the distributive property. In method A, I can say 30 minus 1, or 30 12s minus one of those 12s will give me 29 12s. And in method B over here, I have 20 12s plus 9 12s. And I know that this number will be easier to work with. And over here, these numbers will be easier to work with than just doing 29 times 12. So I'm showing you two different ways. I have subtraction over here and addition over here. Now, if I go with method A, I have 30 times 12 minus 1 times 12. On this side, I would be doing 20 times 12 plus 9 times 12. Do you see where the 20 and the 9 come in when we're using this method? And over here, the 30 and the 1 come back. The 12s is what I'm multiplying each part by. And so, I had a little error here, just ignore that. When I actually do what's in the parentheses first, 3 times 12 is 36, and there's 1 0. 1 times 12 is 12, and I subtract, I get 348. On this side, 2 times 12 is 24, 1 0, and I'm adding that to 9 times 12 is 108. When I add those, I get 348. As you can see, we have the same answer, but I used two different methods to get there. This is a big combined strategy that you can use when you're doing mental math, that you can use to solve multiplication problems, that you can use to break the number that you're given in a word problem into an easier number to work with. And it's just another example of the different kinds of multiplication strategies that we've been learning. You might even see some problems that are similar to this one in your work packet for this week, and this is a really great example that you can come back and reference. To finish out this word problem, Anisha's puppy will have 348 feet squared of play space. A lot of people wonder about this feet squared. This just means that we have two dimensions. That yard, it has a length and it has a width, or it has a base and a height. We're multiplying two numbers, so this 2 indicates that we have two dimensions. And we would just read that as feet squared. That indicates that we did an area problem. All right, let's move on to the next section of our notes. This you do have to write. So problem 1, we have directions that say represent units using first the tape diagram and then the area model. So our lesson is now starting to have us compare some strategies to see which strategy is the best. In your opinion matters too. So when you're trying out all of these different strategies, if you decide, you know what, I really understand and I like the tape diagram, use that one. If you really like the area model, use that one. If you prefer the standard algorithm, use that one, but only if you're getting the answers right with the standard algorithm. All right, so let's try this out. We have 21 times 5. I'm thinking that's really 20 times 5 and then plus 5 more, right? That extra 5 more. So if I drew a tape diagram, this would take forever, right? I'd have to do 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 until I had 20 5s in a row, all in boxes. So I showed that with this dot, 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 and then one more box at the end for this plus 5 more. Then I would have to go through and I would have to add them all. 5 plus 5 is 10, plus 5 is 15, plus another 5 is 20, and I would have to add the whole thing. I would need a whole nother piece of paper to do that. So is that the best strategy for this problem? Probably not. We have another strategy that we've been working on using the area model where I could show 20 across and 5 down, but look at how many boxes that has in it and look at how difficult that would be to count it because they're so small. Even if I drew it on a big board, it would be hard to count all of those. So I put a sad face here because these aren't going to be working super well for us. Will they get us the answer eventually? Absolutely. But is this the most effective strategy that we can pick to solve this efficiently? Probably not. So another strategy that we have to solve this is the area model. That's turned on its head and we don't draw the boxes inside. So we can refer to this as the matrix. In these lessons, the matrix will be standing up vertically, but you can also turn it sideways, and I'll show you that in the next problem. So you can see that I took 21 and I broke it up into 20 plus 1, and then I have my 5 across the top. Now I can multiply 1 times 5 is 5, and 2 times 5 is 10, and I have 1 0 here, so I'm adding on 1 0. Now I add everything that's inside my big rectangle. So I have 100 plus 5 equals 105. You will get the same answer over here with these strategies, but this one was way faster and more efficient. All right, let's flip it over. You might be on a new page in your notebook already. And as you can see, we only have problem 2 and problem 3 left. For problem 2, we're gonna do a multiplication problem that is a 2-digit by 2-digit problem. So you can see the problem here is 23 times 31. I'm gonna keep this at the top for my area model as 23 altogether. I'm not gonna break this up into 2 times 3. We're gonna keep one number all together. And then I'm breaking 30 up into 30 plus 1. And I'm multiplying 23 times 1 is 23. And I know 23 times 3 is 69. I can do that mental math. And there's 1 0. And now we can add everything inside this space to get our final answer using the area model. Another strategy is called the standard algorithm. Make sure in your notes that you're labeling these like I did so that you can point and talk about which strategy you prefer to use. 3 times 1 is 3. 2 times 1 is 2. The reason why this says 23 so far is because this is really like doing 20 times 1 and 3 times 1 since this is in the tens place. Now, I'm not done with the problem. This is where a lot of 5th graders like to stop, but you're not actually done. If you have another number, another place value spot over, you have to keep going. And now I'm starting in the tens place to multiply, so I need to put a 0 here to hold my place value spot. So now it's like I'm doing 30 times 3. 3 times 3 is 9. But 30 times 3 is 90. That's why we need that 0 here. And now finally I'm doing 30 times 20. Really, 3 times 2 is 6. But 30 times 20 would be 600. So that's why we have to add on that extra 0 in another row. Now I add 3 plus 0 is 3. 2 plus 9 is 11. Carry the 1. 6 plus 1 is 7. So our final answer in this is 713. If we add this, we'll also get 713. And I'll show you 2 more strategies. That is Lady Stardust playing with her toy. So the next strategy is the matrix. This should be familiar to you because we've already used this in class, but I'm breaking up both digits now. Whereas in the area model, we kept one of the digits or one of the numbers together, and then we broke up the second number. Here I'm breaking up both. So I have 30 plus 1, 20 plus 3. And now I have 3 times 2 is 6, and there are 2 zeros. 3 times 3 is 9, and there is 1 0. 2 times 1 is 2, and there is 1 0, and 1 times 3 is 3. If I add everything up here, we will get 713. And finally, partial products. This is the strategy that we used on the application problem when we started off the lesson, where I'm breaking 31 up into 30 plus 1, and I'm multiplying each of those parts by 23. I could also break up 23 into 20 and 3 and multiply each by 31. So it's totally up to you how you break them up, as long as you're remembering to multiply by the same factor that you didn't use. And so that strategy is called partial products. Those are just 4 strategies that we've talked about. You might know other strategies for multiplication that work well for you too. We know to use pictures, we know to use our place value charts. So if you already know which strategy you prefer, great. Maybe you also want to try and strengthen another strategy this year. So if you already have the matrix down, keep practicing and keep learning that one, but maybe also learn the standard algorithm or partial products. And if you're not sure yet, then try them all out. As we're going through the packet, try different strategies and see which one works the best for you. Because you could do a problem and it could click in your brain and make so much sense and be very helpful in all of your math. So you have to give them all a shot. And we'll do one more example, and this time we'll make the numbers even bigger. A 2-digit by a 3-digit number. So for problem 3, we're gonna do 343 times 21. And I gave you the area model and the standard algorithm. Now the matrix and partial products would also work for this problem, but I'm only gonna have you practice 2 of these strategies, and if you want to try the matrix or partial products down below, you are totally welcome to. I showed you here 343 times 1 is 343, and then 343 times 20 is 6,860. And when we add those up, we get 7,203. So using the standard algorithm, let's see if we get that same answer, because using more than one strategy to do a multiplication problem is a really good way to get the answer correct. 3 times 1 is 3, 4 times 1 is 4, 3 times 1 is 3. Now we have a number in the tens place, so I'm going to put a 0 here. And I have 2 times 3 is 6, 2 times 4 is 8, and 2 times 3 is 6. When I add those up, oh, look it, we're adding the same numbers together as this problem. We have 3 and 7. Awesome. Thanks so much, 5th grade. Do your best on these practice problems. Try out the different strategies. If you're stuck or if you come to a point where you're not sure what to do next, feel free to ask the teacher, ask someone at your table group. You can try a different strategy that you know a little bit better, get the answer, and then see where you can line it up with the first strategy that you tried. And if you still have questions after that, just write down the strategies that you want more practice on, and we can have more time in class to do those. Have a growth mindset today. You can do this. Thanks so much.